Hello students, welcome to business mathematics class. In this class we will be discussing about determinants. Now before going to determinants, we must know what is a matrix, right? So as you can see in the slide, a matrix is a rectangular arrangement of elements in rows and columns, and it is denoted by a capital letter, say A or B. So let us take a look at the whiteboard. Now if I ask you to write 1 to 9 in rows and columns, you write it like this, and if I put two brackets in between, then it becomes a matrix, and every matrix has an identity. So let us say this is matrix A, right. Now coming back to the slide, what is a determinant? Now determinant is the numerical value that is obtained from a square matrix. Now when we associate a number or a value to a square matrix, it is called as a determinant. Now what is a square matrix? A square matrix is a matrix that has equal number of rows and columns, right. That means the number of rows equals to the number of columns. Now in the next slide you can see I have given you some examples of three matrices. Now they are of different orders. Orders, you know, order is the number of row and the number of column. So the first matrix has only one element, that means it has only one row and one column, right. So the order of the matrix is 1 by 1. Similarly, another square matrix, the following one, it is a matrix of order 2 where there are 2 rows and 2 columns. Similarly, next one, order 3 where there are 3 rows and 3 columns, right. Now if A is a square matrix, then the determinant of that matrix is written as DET, the short form of determinant, A, the matrix identity, or you can write A in between two vertical lines, or you can put the delta sign. So the delta sign is a small triangle shaped sign, it is the symbol for determinant, right. Okay. Now let us find out the ways of finding out the determinant of matrices. Let us start with matrix of order 1. Now order 1 means there is only one row and one column, that means it has only one element. So you can see in the slide it is written first order determinant where there is one row and one column, and it consists of only one element. Now in a matrix of order 1, the determinant is the element itself, that means whatever lies in the matrix is the determinant value, right. Now let us go to the next slide. It is to find out the determinant of a matrix of order 2. Order 2 means there are 2 number of rows and 2 number of columns, right. So how many elements are there? There are 4 elements. Now the value is determined by multiplying the elements of the principal diagonal and from there subtracting the product of the elements of the opposite diagonal. So as you can see in the diagram, so if A is a matrix, so there are position of each element. So you can see the matrix consists of 4 elements, A11, A12, A21, A22. So A11 means 1 signifies the position of the element. So 1 signifies row position, other one signifies the column position. So A11 means first row, first column. A23 means second row, third column, right. So here in a matrix of order 2, how do we find out the determinant? Now we multiply the principal diagonal elements first. So let us say the principal diagonal elements are, so the first element, the diagonal element is the principal diagonal elements, right. So A11 to be multiplied with A22 and subtracting therefrom the opposite diagonal elements. So you can see in the diagram it is very well represented. Next, now I have taken some examples as you can see. So this matrix or this determinant consists of 6, -1, 9 and 4, right. Now how do we find out the determinant? Let us take a look in the blackboard, right. So if I have to find out the value of this determinant, so it is written 6, -1, 9 and 4, right. So first I have to take the product of the principal diagonal. So how do we know which one is the principal diagonal? So we see the first element, right, and its diagonal, they form the principal diagonal elements, right. So 6 and 4. So we take the product of 6 into 4 and therefrom we subtract the product of the opposite diagonal, right. So minus minus 1 into 9, right. So, then we find out the product. So, this is 24 and this is minus 9. So, when we add it up it becomes 33, right. So, this is how we find out the determinant of a matrix of order 2, right. So, let us take a look at the slide. Similarly, another example I have given you in the slide. You just have to cross multiply the diagonal elements. So, the answer is 7, right. Now, next, how do we find out the determinant of a matrix of order 3? Order 3 means there are 3 rows and 3 columns, right. So, basically there are two methods. One is the Saris expansion method, another one is the expansion method using any row or any column. So, we will start with the first method, that is the Saris expansion method, right. So, now Saris was a mathematician. He developed a very simple method to find out the value of determinant of a matrix of order 3, right. Now, as you can see in the slide, there are 4 steps, right. Now, I'll give you an example. I'll show you with the help of an example how to find out the determinant value of a matrix of order 3 using the Saris expansion method, right. Now, let us take this example. Let us say I have to find out the determinant value of this determinant, right. Now, what is the first step? As you can see in the slide, repeat the first 2 columns and add it to the determinant to make 5 columns. So, here what we do? We repeat the first 2 columns and add it to the next to the last of the third column, right. So, we repeat. So, this we repeat 1, 4, 7, again we repeat this column 2, 5 and 8, right. Okay. What is the next step? The next step is you have to find the product of the diagonal elements, right, going downwards, starting from the top going downwards, and you have to find the diagonal product of all the parallel diagonals lying to each other. That means, so this is the first diagonal. So, let us take 1 into 5 into 9, then add it to the next parallel diagonal. So, that is 2, 6, 7, 2 into 6 into 7, then add it to the next parallel diagonal, that is 3 into 4 into 8, right. So, what do? We took the product of the 3 parallel diagonals going downwards, right. Now, we add it up and therefrom we subtract the product of the upwards diagonals, right, upward diagonals. So, starting with 7 into 5 into 3 plus 8, 6, 1 plus 9, 4, 2, right. Right. So, we add this product, therefrom we subtract the product of the opposite upwards diagonals, right, and whatever answer we get, that is the determinant value, all right. So, we can take a look at the next slide to have a better understanding of the Saris expansion method. So, let us take a look at the slide. Let us say we have the determinant A, B, C, D, E, F, G, H, I. So, what is the first step? The first step is we repeat the first 2 columns and add it to the determinant to make it 5 columns. So, first 2 columns are repeated, as you all can see. Then what do we do next? We take the product of the diagonals starting from top to bottom and then bottom to top, right. It is well illustrated in the slide, as you can see, right. Then we take the difference of both the products. So, this is how we find out the determinant value using the Saris expansion method. So, let us now go to the next method of finding out the determinant of a matrix of order 3, right. So, earlier we know the other method was Saris diagram method. Now, this is the expansion method using any row or any column. So, let us take a look at the slide. Now, we know in a third order determinant, we have 3 rows and 3 columns. There are 9 elements. Now, we must know that every element has a positional sign. That means, the sign of the position that it lies, right. Now, how do we know what is the position sign of the element? Now, let us take for example, A11. So, when I say A11, that means first row, first column. Now, what do? We add the row number and column number to find out the value. Now, 1 plus 1 means 2. So, if the resultant value is an even number, the sign is positive, that means plus. When the resultant value is negative, odd number, then the sign is negative or minus, right. So, as you can see in the slide, it can be determined by the position of the element. If the row number plus column number equals to even number, then the sign is plus, and if it is an odd number, then the sign is minus, right. Now, so for an order 2 determinant, as you can see in the slide, when I take A11, so 1 plus 1 means even number, so the sign, so it is 2, so 2 is an even number, so the sign becomes positive plus. Similarly, A12, so 1 plus 2, 3, so the sign becomes, the resultant is odd number, so the sign becomes minus. Similarly, A21 minus, A22 plus. For an order 3 determinant, same rule. So, even number means plus, odd number means minus, right. So, the easiest way to remember is to remember the diagram, plus minus minus plus for order 2 and plus minus plus, minus plus minus, plus minus plus, the order for order 3, the positional signs for the order 3 determinant, right. Okay. Now, how do we use the expansion method, right. Now, there are some steps to be followed. Now, let us take a look at the slide. Now, the value can be found out by expanding the elements by any row or column with a positional sign and multiplying with its determinant. Now, in an order 3 determinant, we know there are 3 rows and 3 columns. So, we can expand it by taking any row or any column. So, we can take row 1, row 3, column 2, column 3. So, basically there are 6 ways of finding out the value of the determinant. So, there are 9 elements, right. So, here we must remember, we must convert it to a second order determinant of the elements that we take along the row that we are expanding. For example, if we are expanding the first row, so when we take the first element of the first row, so we must take the positional sign of the element and also the second order determinant that we find out by deleting in which the element lies, right. Now, for example, take a look at the slide. Now, generally we expand it, we find the value of the determinant by expanding along the first row. Generally we take the first row, but the answer will be the same irrespective of any row number or row, any column you expand, right. So, let us say this is the determinant A. So, as you can see, the signs, the positional signs are mentioned above, plus, minus, plus. So, when we are taking the first row, now we have to now you see, then the determinant of A is, so A11 is the first element. What is the positional sign of A11? Plus. So, plus A11, and we take the determinant that of that element. Now, how do we find out the determinant of that element? We see A11 lies in a particular row and column. So, we delete that row and that column in which the element lies, and the resultant elements is the determinant of that element that we take into consideration. So, as you can take a look into the slide, you can understand it better. So, when first row consists of A11, A12 and A13. So, when we take A11, we are deleting the row and column in which A11 resides, and the resultant is A22, A23, A32, A33. Similarly, when we take A12, again A12 lies in a particular row and column. So, we are deleting the row and column in which the element lies, and the resultant elements is the determinant of that. So, what we are doing? We are converting the third order determinant into second order determinants to find out the values, right. And then we know how to find out the value of a second order determinant. We cross multiply the diagonal elements and thereby getting the value of the determinant. Now, let us understand it better with the help of an example, right. Okay. Now, let us take this example. Let us take this example. So this is the determinant. Now, we have to find out the value of this determinant with the help of the expansion method. So, generally like I said, we take the expansion of the first row. Now, let us take the first row. So, we are expanding along the first row, row 1, right. Now, how do we do it? So, we take three things first. We take the positional sign. So, first row, so the first row positional sign is plus, minus and plus. So, we take the positional sign, then the element, right, and then we take the determinant that we get after taking into consideration the element that in which it lies, right. So, how do we get the second order determinant of the element? We delete the row and the column in which the element lies, right. So, one lies in this row and this column. So, the resultant elements are the second order determinant that we get. So, 5, 6, 8, 9, right. Similarly, the second element, what is the sign? Minus the positional sign, the element, and then the second order determinant. How do we get it? We delete the row and the column in which it lies. So, 4, 6, 7, 9 are the resultant elements. So, 4, 6, 7 and 9. Right. Similarly, next element is 3, the positional sign is plus. So, plus 3, and then how do we get the determinant? So, we delete the row and the column in which it lies, and the resultant elements is the second order determinant. So, 4, 5, 7, 8, right. Now, we know how to find out the determinant of a second order. So, we just do that. So, we cross multiply the diagonal elements and then we take the difference. So, 5 into 9, 45, 6 into 8, 48, right. Similarly, 4 into 9, 36, 6 into 7, 42, right. Again, 4 into 8, 32, minus 5 into 7, 35, right. So, we get minus 3, this is minus 2 minus 6, so plus 12. And this is 3 into minus 3 minus 9, right. So, the resultant is 0, right. So, this is the value of this determinant, this is the value of the determinant, right. So, here what we are doing, we are expanding along row 1. Now, like I said, there are 6 ways, that means since there are 3 rows and 3 columns, we can expand it along whichever line we want to, but the resultant, the value will be the same. Now, let us prove this, let us see if the value comes the same or not, right. Now, if I am expanding along column 1, column 1 means here, this one, right. So, column 1, so first the same steps we have to follow. So, the positional sign is plus, minus and plus, right. So, we take positional sign, the element and the second order determinant that we get. Now, how do we get it? Same method, we delete the row and column in which it lies. So, the resultant elements are 5, 6, 8, 9, right. Similarly, positional sign minus, so we are expanding along column 1, remember. So, minus sign, positional sign, element is 4. Now, what is the second order determinant that we get? We delete the row and the column in which it lies. So, what are the resultant? 2, 3, 8, 9. So, 2, 3, 8, 9 is the second order determinant that we get by taking into consideration element 4. Last one, positional sign is plus and element is 7. Same second order determinant will be 2, 3, 5, 6, right. Now, simple how we find out the value of the second order determinant. So, we get 45 minus 48, this is 18 minus 24 plus this is 12 minus 15. So, we get minus 3, minus 4 minus 6 is minus 24, this 7 into minus 3 is minus 21. So, what is the resultant answer? The resultant is 0 again, right. Right. So, that is the value of the determinant. So, whether we expand it along R1 or column 1, the resultant will be the same, right? Okay. Now, let us get back to the slide. So, let us look at some other examples as you can look into the slide. So, here is another determinant where we have found out the determinant value using the expansion method along the row 1. So, row 1 has elements as you can see 2, -3 and 1. So, here we have taken the positional sign as well as the elements. So, first element is 2 where the positional sign is +2 and again we have found out the second order determinant of the element. Again we can see in the slide -3, here the positional sign after taking into consideration becomes +3. So, -3 then the second order determinant of the element and then again finally, the last element of row 1 that is 1 and the position sign is plus alongside the second order determinant that we found out by using the element, right. So, this is how you solve it and we get the answer as 49, right. 1. So, here we have to be careful about 3 things. First is the positional sign, the element and the determinant, the second order determinant that we get by using the element into consideration, right. So, here as you can see in your screen, the answer is -52. Okay. So, let us do a quick revision of what we discussed today. So, we discussed about what is the determinant. Now, determinant is basically a numeric value that is obtained from a square matrix. So, a square matrix is basically where the number of rows must be equal to the number of columns. Then, how do we find out the determinants of different orders? So, order 1 where there is one element, that means one row and one column. Here the value of the determinant is the element itself. And secondly, how do we find out the value of a matrix of order 2? Let us see. So, if I take this example 5, 6, 3 minus 2, right. So, how do we find out the determinant value? We multiply the diagonal elements and take the difference therefrom, right. So, 5 into -2, then therefrom taking the difference 3 into 6 into 3. So, -10 minus 18 we get -28, right. So, this is how we find out the determinant value of a order 2, right. Now, how then we revised about, then we spoke about the determinants method to find out the value of determinants by using Cyrus expansion method and also expansion along the row or column, right. In Cyrus expansion method what we did? We extended the determinant by repeating the first 2 columns and adding it to the right to the determinant, and then we multiplied the downwards diagonals and then we therefrom taking the difference from there of the upwards diagonal, we find out the value of the determinant. Then another method we discussed about the expansion method, where for example, we took 1 2 3, 3 1 4, 4 1 2. So, how we find out the value of the determinant? By either expanding along the rows or expanding along the columns, right. So, this is how we find out the value of a determinant of a matrix of order 1, order 2 and order 3, right. So, in the following classes we will discuss more about determinants. So, the next class we are going to discuss about the properties of determinants and how we can use these properties to simplify our calculation and solve determinants problems. In the earlier class, we have discussed about what is a determinant, how to find out the value of a determinant of order 1, 2 and 3. So, in this class, we will proceed to the next topic, that is the properties of determinants. Now, what do you mean by properties? Properties are basic rules that help you to solve problems of determinants. That means, they simplify the calculation, they make things easier. So, we are going to discuss about these properties and how we can use these properties to simplify, to find out the value of the determinant, right. So, let us take a look at the slide. So, the first property is the value of the determinant remains unchanged if both rows and columns are interchanged. So, now let me explain to you better. Now, I will take an example of order 2. Let us say this is the determinant. Okay. Now, if I have to find out the value of the determinant, we all know how to find out the value of a determinant of order 2. We multiply the diagonals and find the difference and the value is the determinant. So, this is 70 8 into 9, 72. So, the value is minus 2, right. Now, the property says that the value will remain unchanged, that means the same value will be there even if we interchange the rows into columns or the columns into rows. So, let me change the rows into columns. So, let us say if I put 7, 8 in the column, again 9, 10 here. So, now let us find out the determinant value. 70, 7 into 10 minus 9 into 8, 72. So, see the same value. So, that means if we interchange the rows into columns or the columns into rows, the value will remain unchanged, right. Now, let us take the same property and explain it with the help of a order 3 determinant, right. Okay. Okay. So, let me see. So, if I take an order 3 determinant, and let us find out the determinant of this order. So, we have all discussed in the earlier class how to find out the determinant of an order 3 matrix. So, if I am now I see there is a 0 in row 2. So, I have told you already that try to take a row or column where 0 is there, so that it will simplify your calculations. So, if I expand row 2, right. So, now row 2 means you have to be careful with the positional signs. So, this is minus, this is plus and this is minus, right. So, minus 6, the element and the determinant I have told you to delete the row and column in which the element exits. So, that means minus 3, 5, 5, minus 7, right, 0. So, 0's positional sign is plus 0. So, the ultimate result will be 0, but still for your understanding I am putting the determinant elements. So, here, so this is the row and column. So, the resultant elements are 2, 5, 1, minus 7, right. Now, we take the third one, the positional sign is minus, minus 4, and the determinant that we get by deleting the row and the column in which the element exits, 2, minus 3 and 1 and 5, right. Now, we do the calculation. So, minus 6, this is 21 minus 25 plus the result will be 0, because 0 multiplied with 0 is 0, minus 4, here we get 10, minus 3, so it becomes plus 3, right. So, here we get minus 6 into minus 4, that is 24, right, plus 0, and here we get minus 4 into 13, that is 52. So, we get minus 52. So, the resultant is minus 28. So, this is the determinant of, this is the value of this determinant. Now, if we use the property, that means it says that if we interchange the rows into columns or the columns into rows, the value will remain unchanged. Now, you remember the determinant value has come to minus 28. So, now let us interchange the row into column. Now, for your understanding, I will write down the determinant value over here, so that we remember it is minus 28. Now, if I change this row into this column, that means I change row 1 to column 1. So, I write 2, minus 3, 5, 6, 0, 4, 1, 5, minus 7. So, I have interchanged the rows to columns and the columns to rows. Now, I am expanding, let us say, which one do you want? Let us say row 1. So, I am expanding row 1 and trying to find out the value of the determinant. So, the positional signs plus, minus, plus, right. So, 2 again. So, we know this already, how to convert it to a second order determinant, minus 6. So, here 3, minus 3, 5 and minus 7, here plus 1, So, this second order determinant minus 3, 0, 5 and 4, right. We do the calculation, minus 20, here we get 21 minus 25, here we get minus 12 minus 0, right. So, here we get minus 40, minus 6 into minus 4 plus 24 plus this is minus 12. So, again the result you can see minus 52 plus 24. So, the result is same, right. So, here the property is hence proved. So, if it is order 2 determinant or order 3 determinant, the property remains true that if we interchange the rows into columns or the column into rows, the value will remain the same. So, earlier also we found out the value was minus 28. So, here also after interchanging the value remains the same, right. So, hence proved property 1. Now, let us go to the next property. As you can see in the slide, it is written that if any two adjacent rows or columns of a determinant are interchanged, then the sign of the determinant changes, right. Sign of the determinant changes. Okay. Now, let me explain it with the help of your example. Okay. Let me take the same example 7, 8, 9, 10. I am taking an order 2 determinant for simplification. Let us say 10. Okay. Okay. How to find out the value of a second order determinant? We have already discussed 7 into 10 minus 8 into 9. So, that is 70 minus 72. The answer is minus 2, right. Now, the property says that if any two adjacent rows are changed or any two columns, right, are changed. In the first property, the rows were changing into columns or the columns were changing into rows, but here it is saying row 1 will become row 2 or row 3, column 1 will become column 2 or column 3. So, there is interchange between rows and columns, not interchange among them, right. So, let us say here row 1 will become row 2. So, I am placing 7, 8 in row 2. So, 9, 10 here and 7, 8 in row 2, right. So, now 9 into 8, 72, 10 into 7, 70. So, the value is same, but the sign has changed. That means, here it was minus and here it has become plus 2. So, now the property is understood. That means, if any two adjacent rows, so if row 1 will become row 2, the value will remain the same, but the sign will change. So, you have to remember that if the rows are becoming into columns, the value remains the same, but if there is interchange between rows or C1 will become C2 or C3, then the value remains the same, but the sign will change, right. So, here in the property 3 we discussed that if in a determinant any two rows or columns are identical, then the value becomes 0. So, I already showed you that in a determinant of order 2, if row 1 is equal to row 2, equal to means the corresponding elements are same, then the resultant is 0. Now, similarly, if I show you with the help of a determinant of order 3, let us say 1, 2, 1, 2, 2, 4, 3, 2, 1, 2, 1, right. So, here we can see that row 1 is same as row 3, right. Now, let us find out the determinant. So, we know how to find out the determinant. Let us say we are taking row 1, we are expanding it. So, this positional signs are plus, minus, plus. So, we get the second order determinant by expanding the first row elements 2, 4, 1, 1. Then again element 1 has the second order determinant as 2, 2, 1, 2, right. So, here we get 2 minus 8, here we get 2 minus 4, here we get 4 minus 2, right. So, here we get minus 6 minus 2 into minus 2, that becomes plus 4, and here we get plus 2. So, the resultant is minus 6 plus 6. So, 0. So, hence proved. So, that means if in a determinant the row or the column, right, they have identical twins, that means the corresponding elements of another row or column are same, then the value comes to 0, right. Okay. Now, let us go to the next property. Now, the property 4 says if each element of a row or a column of a determinant is multiplied by a constant k, then the value of the determinant becomes the k times the original determinant, right. Okay. Now, let me show you with the help of an example. Okay. Let us take order 2 determinant, right. Okay. Now, here I am taking 3, 2, 5, 6, right. So, what is the value of the determinant? 3 into 6, 18 minus 2 into 5, 10. So, here it is 8, right. Okay. Now, the property says that if in any row we multiply it with a constant, that means any row or any column, but all the elements of the row or the column. Let us say if I am multiplying row 1 becomes k row 1, here the k is the constant. Let us say I am multiplying row 1 elements with 2, right. So, now the new determinant will be 2 R1 elements. So, 2 into 3 again 2, 2 into 2, right. Same row 1 will be the same, right. So, 5 and 6. Remember, whenever you are multiplying the constant, you must multiply it with a single row or a single column. You cannot multiply with all the elements here, then the rule will change, because it will not become 2, it will become 2 if you are multiplying with all the elements. Let us say 4 elements means 2 into 2, it becomes 4, 2 square. So, it does not hold true. So, remember, you have to multiply the elements of a single row, all the elements of single row or all the elements of a single column. So, here the resultant elements is 6, here 4, here 5 and 6, cross multiply 36, here minus 20, 16. Now, what does the property say? Now, if you multiply any row or any column with a constant, so here the constant is 2, then the value of the determinant will change to k times the original determinant. So, the original determinant value is 8, constant is 2. So, here 8 into 2. So, the value is 16. Got it? Now, you can use it in a determinant of order 3 as well, and you are going to get the same result, right. Okay. Now, let us go to the next property. Property 5 says that if every element of a row or column of a determinant is expressed as the sum or difference of two terms, then the determinant can be expressed as sum or difference of the two determinants, right. Now, what does it mean? Now, let us see with the help of an example. Here we are going to take a order 3 determinant. Now, it's in the property it is told that if every element in a determinant or every element of a row or a column is shown as a sum of or difference of two terms, that means there are two terms in a particular row or in a particular column. Let us say A plus B, C plus D, E plus F. So, here in row 1 there are two terms A and B, and the algebra is plus, right. Now, in the remaining elements G, H, I, J, K, L, right. So, according to the property, you can split this into two determinants. That means, you can write it as A, C, E, G, the remaining elements remaining the same, I, J, K, L. Here the algebra is plus, so sum, so plus the next term, right. So, B, D, F, again the remaining elements remaining the same, G, H, I and J, K, L, right. So, here we have split the single determinant into 2 determinants. Now, remember in matrices how we add or subtract, we, for example, if this is one matrix and this is another matrix, let us say with A and B. So, this is another matrix, let us say 5, 6, 7, 8 in matrices. So, how do we add in matrices? We add the corresponding elements like this, like 1 plus 5, 2 plus 6, 3 plus 7 and 4 plus 8. This is how we add in matrices. We add the corresponding elements with the other matrix, right, and the resultant is the 6, 8, 12 and 12. So, this is the additive value of the two matrices, but in determinants that is not how you must add. That means, whenever we are splitting the determinants into 2, then you have to find out the value of this determinant and then add the value of the other determinant that you derive. So, we do not add the corresponding elements, but we find out the value of the determinant and then we find out the value of the other determinant and then we add the determinant values to get the final value, right. Okay. Now, let us go to the next property. Now, the last property says that if any row or column of a determinant, a multiple of any other row or column is added or subtracted, then the value of the original determinant remains the same. Now, what does it mean? Now, let me show you an example. Let me take the example of an order 2 determinant. Okay. 2, 3, minus 2, 4. Okay. All right. Now, the determinant value is how much? 2 into 4, 8, minus 3 into minus 2 is minus 6. So, the resultant value is 14. Now, the property says that if any row or column we add a multiple of another element of any other row. What does it mean? Now, you know this is row 1 and this is row 2, right. If I write that row 1 means row 1 plus 2 are 2. That means, here we are adding the multiples of another element of another row and making a new element, right. So, the new determinant will be, so row 1 will now become, will follow this equation, that means row 1 plus 2 row 2 element. So, here 2 plus 2 are 2. So, what is the row 2 element? Minus 2. So, here 2 into minus 2, right. Again next element, that is the next element of the same row, 3. So, we write 3 plus 2 are 2, the element is 4. So, it will be 2 into 4, right. Row 2 will remain the same, that is minus 2 and 4. Okay. Now, how much this is? 2 minus 4, that means this is minus 2, 2 plus minus 4, right. This is 3 plus 8, 11, this is minus 2 and this is 4. Okay. So, here we get how much? Minus 2 into 4 is minus 8, minus this is minus this will become plus 22. Resultant will be the same, right. So, did you see the property getting true? That means, if we are adding or subtracting, if I had been minus, then the same thing, the value would have not changed, right. So, according to the property, if any multiple of any row or column is added or subtracted, the value of the original determinant remains the same, all right. Now, if we use the same property in an order 3 determinant, like say for example, this problem we have already discussed it, we have found out the determinant to be minus 28. Now, remember, if I say row 1 is row 1 plus 2 R 2, that means here I have used a multiple of another element of another row. So, if I convert it, let us say, so row 1 is now row 1 plus 2 R 2. So, that is 2 plus the corresponding row 2 element, that is 2 into 6 here again minus 3 plus 2 into 0, again here 5 plus 2 into 4, right, and the remaining elements remaining the same. So, 6 0 4 1 5 minus 7. Now, remember, even if we use it in an order 3 determinant, the resultant will be the same. You may solve it and find out the result for yourself. Okay? So, here we have discussed about 6 properties of determinants. We can also add another property of determinant here, which says that if in any row or any column of a determinant there are only zeros, that means the elements are only zeros, then the value of the determinant also comes to 0. Now, what is the importance of the properties? Now, basically the properties are there to use to make our calculations and solve solutions easier, simpler. That means, if there is a determinant where the elements are of 2 figures, 3 figures, so how do we make it simpler? We can make 2 rows or columns identical, or we can interchange the rows and columns, or we can make 1 column or 1 row only zeros, so the value will become 0, right. So, basically these properties are used to make our determinants, make our calculations easier and simpler, right. So, now let us do a quick recap of what we have studied so far. So, we have discussed what is a determinant, how to find out the value of a determinant of a matrix of order 1, order 2 and order 3. We have discussed, in order to find out the determinant value of a order 1, then the value is the element itself. Order 2, that is, we are finding out the product of the diagonal elements, finding out the difference and then the determinant. Order 3, we have 2 methods, the Saris expansion method and also the expansion method by usage of any row or column, and finally the 6 properties that we have discussed. So, in the following classes we are going to discuss how to find out the minors, the cofactors and the use of Cramer's rule. Thank you.